Joining us today, we have Dr. Jim Huggett, recipient of one of the 2023's Positive Droplet Awards. Dr. Huggett, congratulations on your award, and thank you for all the hard work that you've contributed over the years in the field of digital PCR and the advancements of digital PCR.
It's great to be here. Thank you very much.
Can you tell us a little bit how digital PCR intermeshes in your current and past work?
So I guess if we go back quite a long time ago, when I was working at UCL, we were mainly using qPCR. I was first introduced to qPCR when doing my PhD at Cardiff University, again, the late 90s. We had one of the early instruments out of the Idaho technology, and it was fiddly, we would say in the UK, quite a difficult method to get working. And I was doing my PhD on this topic of quantifying nucleic acids, and decided at the end that I would never quantify nucleic acid again in my life, because it gave me such a headache. I then moved to UCL, where we were looking at developing diagnostic methods for respiratory pathogens in the developing world, tuberculosis mainly. And the first thing they asked me to do was, you've worked with qPCR, could you help us with setting up these 5 instruments across sub-Saharan Africa? So it was kind of a curse. Anyway, that got me very interested in standardization and trying to understand how we can get qPCR to work robustly and reproducibly. But one of the things I felt when I was doing it, and possibly it's due to me, was it was quite a difficult method to get to work reproducibly, particularly across laboratories. And low signal trace analysis was very, very challenging. So when I moved to the National Measurement Laboratory here at LGC, they say about 14 years ago, and they had just bought one of the early digital instruments, which is a chip-based instrument, and they were telling me that this worked by measuring single molecules, and that really opened my eyes to what was possible at this single molecule detection level. And while people have used, they look at digital PCR for its advantages at measuring rare variants, increased precision. What really hit me, bearing in mind I'd spent 7 years working across laboratories in sub-Saharan Africa, was how robust and reproducible it was. qPCR, you're trying to get results to compare. Immediately, you've got to think, well, how am I going to calibrate this? How am I going to standardize those different laboratories? What am I going to use? Will it be stable? How do I ship it? Major headaches. But it was immediate to me that this technology was just much more robust. It was counting the molecules, and when you compare it to qPCR, it was giving you much more reproducible results. And so to me, that was the major advantage. But it is an example of where the measurement institutes have really championed a technology in bioanalysis, because it gives us this high reproducibility, and we may come to in the discussion, increased potential accuracy. So that's where we're really interested in trying to look at how accuracy is delivered using this technology.
Well, absolutely. I mean, this basically dovetails into a comment I have, which was that paper that Bio-Rad actually collaborated with, that inter-lab study of 21 labs looking at rare event detection. And the results were outstanding, regardless of the user, of the facility, how much coffee they have had that morning, which is a bit of a running joke, because anybody who's done enough qPCR knows that, or pretty much any scientific application knows that that's an important parameter, how much coffee you've had.
You've got to get the balance right. You need enough, right? But not too much. No, that study was quite amazing, because that not only showed the absolute quantification was robust and reproducible at very low copies, you took in tens of molecules. That was also rare event detection. So you're also dealing with this competitive PCR where the primers are binding 2 subtly different versions of the same molecule, and that probe has to find them. And we found that, yes, of the multitude of laboratories, I think there was 3 that were outliers, but when we actually looked at the data set, it was basically they were not setting their thresholds quite right. And so when you did that, again, everything fell into line. I say this, and I've said this to you before, Frank, it's just much easier for you and I to get the same result with digital PCR.
One of the things that you hit on is digital PCR provides an absolute value. Do you think that this absolute numerical value that you generate can lead people down a false sense of security.
Absolutely, it can, and I'm really glad you asked me that, because one of the things we're trying to do at the Nucleic Acid Analysis Working Group at the moment, amongst the BIPM, the Bureau of Weights and Measures, is to really look at that, because we're spending a lot of time understanding the sources of error that may impact on that result, and also trying to stop people going, I'm doing digital PCR, I've got perfect accuracy. That cannot be assumed. It must be demonstrated. We're measuring all the molecules. But we need a lot of work to be sure that we are measuring all the molecules. And so you cannot just jump into that. Yes, I mean, the digital PCR, it's going to be far closer to the truth than just running a qPCR, because a qPCR, the CQ value or CT value really is meaningless without some kind of calibration. I know it was used a lot in COVID. It shouldn't have been, but anyway, we can have that for another time. That digital count gives you a good position of where you are. Probably, within tenfold. You have to really be pushing the instrument to be out that much. But no, there must be considerations for when measuring accuracy. And digital PCR can only work with the nucleic acid you give it. And we all know that the extraction, the sampling, these are big sources of error as well. And so we have to be, and we are at the moment looking at these types of areas and what is meant. What do we mean in terms of accuracy when measuring X genome copies of HIV, given that there's, the RNA is being measured to guide patient treatment, and people may think, well, that's an active virus. There's a whole almost philosophical world as to what does a nucleic acid mean? Amount of nucleic acid mean, even if you understood what it was. Yeah. But then you also have the fact that the digital is only measuring, 80, 90, 150, depending on the size of your amplicon, regions of that. And so you may have situations where you're measuring, a single nucleotide variant in a liquid biopsy, where there are quite a few molecules that are smaller than the amplicon. So the digital PCR is not picking them up.
Mutated.
It's not, the digital PCR
Yes.
Still working with great accuracy with the molecules it's trying to find, but because of biological reasons, they may be there, the variant is there, but you cannot see it. And so we have to, there's a lot of discussion around that. And ultimately we're talking about using digital PCR as a reference method in this context and trying to work out what we need to consider and avoid the pitfalls. And
I don't know if you're able to talk, but what are your future projects with digital PCR?
So we have a range of different projects at the moment. In the precision medicine space, we're looking at increasing the multiplexing, trying to understand, measuring more targets and how does that impact on the accuracy of the method, and are there simple routes to try and support people doing that. We're increasingly interested in synthetic biology, biotechnology. We mentioned the CRISPR. I touched on CRISPR, but using digital PCR to interrogate the performance of CRISPR events. And I raise that as because interesting conversations with people go, well, I don't really care how well the CRISPR. I'm just going to I select clones and choose the one I want. It takes me a day and I've got it. I don't need to worry about this. And this is I really like it when people are on it and challenge that, because that is a valid argument. However, if you're using this as a therapy, or if you're working and you're trying to choose a process that will increase, to a bioreactor, and one of your model systems gives you 60% efficiency or 60% transcription, and another is 75%, you might go, well, that's in the noise. Well, it is in the noise with qPCR. The digital will allow you to see that, and that could potentially be big numbers of dollars when you scale that up. I guess linked to that is the fact we don't really know what this improved accuracy can necessarily give us until we've got it. And the other area, of course, the big area of we're very interested in is in infectious disease diagnostics, obviously post-COVID. But I think that put a lot of spotlight on the importance of quantitative measurements to support yes-no tests. And this view that we don't need to worry about the quantity for COVID because we're not interested in its quantity. We just want to know it's there or not. And then you see the tests that come through have 1,000, 10,000-fold variation in their limit of detection. That may or may not be a problem. It was a problem for COVID. And so actually, this is where, again, digital PCR can add huge value because it can provide quick, standard support in outbreak scenarios where you can't share materials because all your borders are shut.
No, well, thank you for all your hard work over the years. Having followed your work and tangentially collaborated with your team over the years, You have been a strong advocate, a strong leader in this field, and it's something that we hope will continue. And this award is a small token, but it just says that, hey, we recognize your powerful work and impact.
Thank you. Thank you very much. That's very kind.